So allow me to share my screen. Okay, sorry. If you see so many things running, I hope you won't mind. Let me know if you're able to see my presentation. John?
Yeah, yes, I'm able to see. Thank you.
Okay, thank you. So hello, everyone. My name is Alela Eunice Denise. I am a software engineer by profession and a community manager at Google for the Developer Experts program. I'm super excited to be here with you all. I am not an AI expert, but rather an enthusiast who's interested in the amazing solutions that I feel AI can provide to us, the amazing ideas that we all have and the difference that it can make to the ecosystem. So really super excited to be here with all of you. And I hope you're going to just be able to enjoy the session. It's not a very hard session, so I believe it's going to be free. And if you have questions, feel free to interrupt me because then we are going to be having a meaningful conversation. Okay, great. So each and every industry at this particular point is undergoing a digital transformation. And let's look at it from this angle. When the COVID-19 impacted the whole world, most businesses, most companies moved from the offline model of operation to the digital space in order to keep afloat. So as much as today's conversation is going to be on AI, artificial intelligence, and machine learning, I want us to focus on the word intelligence because together it's all about making these machines as intelligent as possible to perform operations like human beings. So what do we have lined up for the day? The agenda is basically going to be an intro to AI and machine learning. And we're going to talk about what you think AI is, what do you think machine learning is, then what is data, and then a deeper dive into deep learning and neural networks. And then I will be open to questions in case you have any. So before I jump into the definition of AI and machine learning, anybody who feels like giving us an answer to this. So what do you think AI and machine learning is? Just, you can either post it on the chat section or you can unmute yourself and let's talk about it. In your own words, what do you think AI is? Or should I pick randomly? Okay, I want somebody who's not in the tech industry. So Amanda, I am going to put you on the spotlight for this one question. In your own words, what do you think AI is?
I think AI is to do with unreal, since it's artificial. So it's not real intelligence. It's smartness. Okay, unreal smartness. That's how I'll put it. So you're trying to put unreal in the sense that it's not a physical body, and it's a smart, intelligent system you're putting in something that is not human to work.
Yeah. So yes, so you have said two keywords there, not human, but there is the word human there and the intelligence bit of it. Thank you so much, Amanda. Let me pick somebody else who's not in the tech industry. It's a good thing, Joanne, you asked us to put our industries. So I'm going to put this to Nicole, beauty industry. What is AI in your own definition? Nicole? Okay, if she's not able to unmute, we can have John Ngunjiri. John, legal industry and energy. In your own words, what do you think AI is?
Oh, artificial intelligence. So I think it's as close as machines are going to get as far as relating to human brain and thinking.
Okay, thank
you.
Yes.
Okay, go ahead. And machine
so,
learning, I think machine learning is at least my understanding, having read a little bit about that, is the ability of the machine computers to decipher meaning of words and sentences as we would as human beings, and being able to put those meanings from the context in which the words are used.
Okay, thank you, John. So let's jump straight into it. So artificial intelligence is broad, right? And sorry, when you talk about artificial intelligence, two things come into mind. There's the machine learning bit of it, and then there's the deep learning bit of it. Now, let's jump straight into the definitions. Artificial intelligence refers to the simulation. Basically, you're trying to replicate human intelligence as demonstrated by machine. Now, you're probably wondering, how would a machine operate as a human being? This is going to be from a set of examples, but then what exactly is this human intelligence? Now, this can range from how a human being thinks about issues to how you actually perform something. Let's say it's from how you think about picking that tea bag to how you go to the process of making the tea itself. Now, as much as AI is the broader, should I say the father of it all, now we have subsets, which is now machine learning as a subset of artificial intelligence. For a machine to be intelligent, it needs data, it needs examples that it can reference to. So there's no way a machine will be able to tell that this is a cup if there was no sample data of how a cup should look like. Or there's no way I would tell that this is a human being if I have no idea, if I am a machine and I have no idea a human being looks like. Now, human beings learn from past experiences, right? Unless if you fall down once, then you know, okay, this process is called falling down. If you jump up a tree, then you know, okay, so I have, no, not up a tree. If you jump over a hurdle, then you know this is jumping. So from past experiences, we're able to actually learn from it. Now, the same way we learn from our past experiences is the same way machines also learn based on what human beings feed it on. Now, in machine learning, the difference, what now happens is you have to state some of the characteristics that you're looking for. So talking of, you have a data set, but you want, let's say you want to describe a dog. And you want the machine to be able to differentiate a dog from a cat. So quick question, randomly, anyone now, because we're all, I don't know if there's a dog or a cat here, but we can all tell the differences based on knowing that this is a dog and knowing how to differentiate it. So I'm gonna pose this back to the group. Joseph, Nancy, and Hazel. In that order, what is that one thing that makes you know that this is a dog and this is a cat? Joseph? Or anybody randomly. I don't want to put anybody on the spotlight.
Hello.
Yes, Hazel.
Yeah, for example, if we want to look at the difference between a dog and a cat, we're going to look at the features of it. We're going to look at the way the nose of the cat is positioned and the way the nose of a dog is. Those are some of the differentiating features that the two animals have that you can use to classify each, either as a cat or a dog.
Yeah, so the keyword was features. Thank you so much, Hazel. Anybody else who wants to go? Catherine?
Well,
Oh, thank you, Doreen.
in terms of sound, a cat would obviously paw, while a dog would just bark. So you can tell the difference from that.
Okay, yeah. So based on sound, but let's look at this example whereby it's an image. So how exactly would you be able to tell the differences based on the image?
Hello.
Yes, Justin?
Yeah, so when you talk about an image, then we can just focus on data points. So the data points of a cat, or the image of a cat, will not be the same as the data points of the image of a dog. So we can classify them differently, sorry, our model can be able to counter check those data points and can classify differently.
Okay, thank you. Anybody else wants to go before we continue? Anybody? Okay, so yeah, so we have talked about, there has been a mention of data points, there has been a mention of features, there has been a mention of characteristics. Now, when it comes to machine learning, you have to state what is it that you're looking for, based on size, let's say, based on the data points, based on past examples that you want to reference to. Now, which now brings us to the difference between machine learning, which is a subset of artificial intelligence, and then deep learning, which is now a subset of machine learning. I'm going to go deep into the deep learning bit, but first let's jump into AI, the types of AI. So at this particular point, we have got to the point where we keep on telling ourselves, oh my, AI is gonna take over. I am going to lose my job to a machine or something like that. But AI has different categories. There are three main categories of AI, and that is the artificial narrow intelligence. Oh, trust me, we win on this. Basically what this is the machine cannot operate better than a human being. Whatever it is that you tell it to do is strictly what it is going to be able to do. So it cannot think beyond the intelligence that it has been trained to do. Then you jump into the general intelligence. Now look at it in terms of a model that has the same intelligence as a human being, cannot reason beyond what a human being would do. So the characteristics are similar to that of a human being. Then we jump to the scariest one, which is the artificial superintelligence. And in this case, imagine a machine that could perform better than you. I don't know if any of you has ever got to a point where you're like, okay, wait, this machine got the answer, but I did not. Or this machine could easily group these items, but I could not. So we have those three main categories of AI. And what basically this means is it's able to, they're differentiated based on performance. So what is one able to do that the other cannot do? Which makes us ask ourselves, at what point are we at right now with the whatever it is that we're developing? When you're going to be coming up with these solutions using AI, what are we going to be targeting? Are we going to be going for general intelligence, narrow intelligence, or super intelligence? I'm going to be sharing a few resources after the class that you can maybe check out, and maybe this can help you make the decision or just help you learn how to train your models in any of these three particular types. Okay, so why exactly is this AI important? I know we've talked about how things are moving to the more digital space as compared to the traditional space of in-person conversations or stuff like that. Now, when you look at AI, you're able to make critical decisions. This basically means that some things that you would want to do, but are not sure about, or you would like to be automated. You don't have to really think about it or sit down with a paper and pen and write them down, but be able to make automatic processes. And when we talk about automatic processes, it would be good to remind yourself that machine learning can help automate processes, yes, but it cannot discover or decide what the correct next step is. Take an example of in a case where you're having applying this in an e-commerce site, right? You want to be able to tell what this person would like. So as much as you're going to be providing these target ads to this individual, you're not going to make this human being purchase the shoes. You're basically trying to convince them or trying to make it pop up on their screen at all times, but not make the decision for them. So as much as it helps us to maybe do things that are beneficial to us, it's not the final decision maker. And this is mostly like in instances where you're looking at e-commerce, it cannot also be based on socioeconomic status. So it can also help us predict future trends. And this is, I want to use another example. Look at the agricultural, let's say the agricultural industry, right? Which last time on the call, many people were on, which was a really good thing to note. Actually, I was kicked out of agriculture class, but at least now I know I have people I can reach out to. So in the agricultural industry, at times you need to know what are some of the diseases that your crops are affecting or are affected by, or what are some of the things that if you expose your animals to is a huge risk. So how are you able to predict that this thing may happen if this is the case scenario? Because you have a set of data sets that you're referencing to. Within this particular duration, let's say, you already know this always happens. So how do you prevent this from happening? How do you make that decision on your own to now shift from the model that you're working with to a new model that helps you know, okay, this is what is affecting my animals, this is what is affecting my plants, and I need to shift to this other model. Or based on these past trends, this is what I need to look out for. Okay, I don't know if that makes sense or I'm just blabbering. Okay, so machine learning is categorized. There are three ways of training, your model. You don't just wake up and train your model. You have to pick what is it that, how do you want to train it? And so in order to train your machine, in order for your machine to learn, you can either use supervised learning, unsupervised learning or reinforcement learning. I am only going to be covering the first two. So as mentioned earlier, I talked about how humans learn from examples, but in this case, these machines have been trained by humans. So in supervised learning, it fully depends on past examples or a given data set. So if you do not have past examples for it to reference to, then it's not able to decide, is this a cow or is this a cat? If you have no data points, if you have no features that you want to remind this machine that this is what this is, then there's no way it's going to actually make a decision. And people, if I speak too fast, just feel free to make me stop. Okay. Great, sorry. So I thought I was speaking too fast, so I had to pause. Then we look
Speed
at
is
now.
okay.
Speed is okay?
Yes.
Okay.
I think you're going so fast.
Oh, okay. So two people, one I'm going so fast, one speed is okay. So the one whose speed is not okay, would you like to tell us where I lost you at?
At the very beginning, when you were explaining the first two that you're going to delve on.
Oh, that's what I'm still talking about, the supervised learning and the unsupervised learning. That part?
Yes.
Okay, great.
Yes.
So in supervised learning, it fully depends on example. Remember, we said machine learns from past examples. There's no way a machine will be able to know the difference between trying to look at things around me, a toothbrush and a toothpaste, if it has no idea what a toothbrush looks like and what a toothpaste looks like. So when you're able to tell these two things apart, when you have a data set that has sample toothbrushes, how should one look like? So remember when everybody was giving examples of the understanding of machine learning, the keyword was the features, the data points, characteristics. So when you're able to tell how a toothbrush looks like and how a toothpaste looks like, that's not your data sets. So these are two classified data sets, like they're categorized. So there's a category of toothpaste examples, and then there's a category of toothbrush examples. So how do you tell the difference in supervised learning is because one item has already been labeled as a toothbrush. I'm trying to use examples from what's around me, so I hope nobody minds. Then the other example is based on another data set that has been labeled as toothpaste. So based on these two things, you're working using examples, hence the name supervised learning. The outcome is actually predictable because there's no way if you're using toothbrush samples, it will give me the result as toothpaste. I don't know if that's clear for the supervised learning, but if you need clarification, feel free to stop me at any point. Is that clear? Can someone like make me know?
Yeah, it's clear.
Okay, great. Then now we come to the unsupervised learning. So
could you please just repeat the supervised learning portion?
Okay. So supervised learning works using a labeled data set, right? Now take these two data sets. I'm going to still use the toothbrush and the toothpaste analogy. So you have one data set that has sampled examples of how a toothbrush should look like, right? Then you have this other example that has a set of data on how a toothbrush should look like. So one data set has been labeled toothbrush and the other data set has been labeled toothpaste. Now, in this case, whatever example that you want your machine to learn from is based on a very, very specific data set. If you want it to learn the difference, it will know what to pick from. So you're training it based on how a toothbrush looks like. If you want it to learn what a toothpaste looks like, you're using the example of what is a toothpaste. So based on these two labels, you're able to tell the difference. Now, in supervised learning, the outcome is quite predictable. chances of you getting an error or a new answer is not easy, because it is using very fixed examples, past examples. It's using the features that you had stated. It's using the data points that you have used to actually declare how something looks like. Then we jump into unsupervised learning. Now this is unpredictable, but you can base it on specific patterns and structures of an item. Now the problem that comes in unsupervised learning is it can end up coming up with new, like extremely new data sets, in that you have no idea what it's going to select, because it's going to randomly pick from whatever it is that it has. It can have a mixture of components, all labeled, not labeled, but it's supposed to pick what does it look like in this particular case. So let's say you're talking about a shoe, sport shoes and, sport shoes and what else? I only know sport shoes. This is quite embarrassing. Can somebody give me another example? There is sport shoes and then there's this heels, sorry, yeah. So you want to be able to tell the difference between sport shoes and then heels. But remember, it has not been categorized. So it's going to randomly pick, okay, how does this look like? This looks like a shoe, or this does not look like a shoe. So in unsupervised learning, it's really hard to predict what the outcome is going to be like. So you're not able to tell what the outcome will be like, but you're able to get an outcome. And this outcome that you get can actually be a new data set altogether. So it can create its own new data set because it could not find what to reference to. So which is also a good thing, because then maybe you know what you're working with. If it was not in any of those categories listed, then you know, okay, so this is something I actually need to include. Any questions on the types of learning for machine learning before we continue? Yes?
Yeah, I have a question.
Yes, please.
So how precise do you need to be with the supervised learning model for it to be considered supervised? Or can it be a rough model and it will still qualify as supervised or not?
So when it comes to supervised learning, the ideal thing is when you're creating this labeled data set, use as much examples as possible, because you want it to be working with sample data sets, examples from the past or examples from things that you have collected. So in terms of for it to be classified as supervised, from my understanding of supervised learning, I think it would only be accurate if it already has samples to reference to. Then it can be classified. But if it does not, if it's random and they're not labeled, if you have a mixture of everything in one place, then that will be categorized as unsupervised learning. I don't know if that makes sense.
All right, thanks.
You're welcome. Anybody else with a question? Anybody with a question?
Yes, I want to explain the reinforced learning for me, please. Shed more light on it.
Reinforcement learning. I think I said I'm going to focus on the first two because I have no in-depth knowledge on reinforcement learning, but I can maybe just give a rough idea of how it works. So it bases its examples from the environments, cumulative items from the environment. So it's learning from its environment, not from something that has been input on it, but it takes actions based on what is this particular environment that it is in. So how can I explain this? I'm trying to find the easiest way from my understanding to explain it with. How do I explain it? It's not supervised, but it's not supervised, but it's not unsupervised also. It's going to base its learnings from where it is. If you are training it to, let's say you're working on a game, my understanding, again, this is not an expert or something, but you're working on a game and you want that if it gets to this particular point, or if this is what's happening, then this is the action that it's supposed to take. So this is the environment that it's working with. But in case anybody else wants to shed some light on reinforcement learning, open to letting you have the stage for at least the next 2 minutes. Anybody?
I could try. From what I understand in machine learning for reinforcement learning, the model basically just learns from trial and error. So what I'll take it in an example of a game-like situation. So every time it makes a prediction, it's like the penalties and the rewards. So depending on the reward it gets, it continues learning from that. So every time it goes to, okay, when it's trained, it learns from the mistakes and the rewards that it gets from the training. I don't know if you understand.
Yeah, and also it's based on a very, very specific setup.
Yeah.
So it has to be that specific setup that it was working with when you were training it first. Then that's what it's going to. I believe that's what Doreen and I tried. I don't know if Doreen, that's what your point.
Maybe I can add on that.
Yes, please.
So on reinforcement learning is where an agent is put into an environment and is supposed to learn from the environment. I think the best way for me to explain this is by giving an example. For example, if you're told GPS, for example, and it's Uber, and it's supposed to find the best route between point A and B. Let's say you're moving from town to maybe Ngong Road. There are very different ways you can use to get there. So for the car itself or the GPS or the phone is the agent, and it will be put in a situation where it should look for the best way to get from point A to B, and it's going to be given rewards based on, in this case, how long it will take between point A and point B. So it will use route A, take 5 minutes, route B, 10 minutes, then route C, 15 minutes. So it will keep on learning. After some time, it will realize every time I use route A, I will get to Gong Road faster. So that is just an example of reinforcement learning.
Okay, thank you.
Clear?
Thank you. I hope it was clear. Let's see, was it clear?
Yes, thank you. Thank you. It's clear. Thank you. Thank you.
Okay, great. Sorry. Okay, so does anybody have a question on this part before we jump into deep learning? We still have some time left.
I can see Amanda has raised her hand.
Yes, Amanda.
Yes, I wanted you to repeat the unsupervised learning using the example of the dog and the cat that you gave in the first one.
Okay, unsupervised learning using the example of a dog and a cat. Great.
That you used in the first one.
So a dog has very specific structures, right? How the nose looks like, how the hooves look like. They're called hooves. I don't know. I've never had a dog before, but anyway. So a dog has like very, very specific structures on how it looks like, how it moves and stuff like that. So take an example, you want to be able to differentiate this dog and a cat, but you have no point of reference on how a dog looks like. So there's no data set that you have used. There's no data collected to show how a dog should look like, but you have a very specific thing to define it with. So the data points, you know, like at this point, this is how the nose of a dog looks like, or this is what you expect it to look like, but there's no particular image that you have used or pixels that you can use to define it. Now, when it comes to unsupervised learning, you have to make the selections quite how do I say, manual selection. So you have to select, let's say, the eyes, like that. It has eyes, it has 4 legs, it has like, this is how its height is. So in unsupervised learning, you're not referencing to anything, but you're coming with very specific patterns, and structures for this particular item. Now you're saying this is how the eyes of a dog should look like. Take an instance when people trying to tell the image of Barack Obama and let's say Joanne. So if this is how Barack Obama's eyes look like, I'm sorry to use Barack Obama, but because I've seen very many people make data sets from that, do unsupervised learning from that. So you're using a very specific pattern of his eyes, like this is how it looks like, and this is how Joanne's eyes look like. In terms of structure, maybe let's say this is how the nose looks like, and this is how Joanne's nose look like. But you're not so sure, it's like trial, but not really trial and error. So you're coming with very specific patterns on how you expect it to look like, but you cannot predict the outcome. Does that make sense? So in a dog and cat's case, you're saying this is how a cat should look like this is how the tail looks like. This is the pattern of the tail. This is how the tail of a dog looks like. This is how the face of a dog looks like in terms of patterns, and this is how the pattern of a dog's shape look like. So you're not being specific. You are actually just basing it on the knowledge that this is how it should look like, but you're not giving it samples to pick from. So based on that, you're going to be the one who's actually stating what these specific features are. What these selections, what are these features that you want to work on? Do you want to use the eyes, ears, and nose, or do you want to use each and every body part, but clustered differently? I don't know if that makes sense. So in unsupervised learning, you can use something called classifiers. You're classifying each and every pattern. This is an eye, this is a nose, this is a what, but you're not giving it a general overview on what it should be working on. So at times you may even say this is a pattern of a dog, but then it ends up telling you this is not a dog. Then when you look at the image, oh, this is a fox. So this gives you a whole new data set to work from. I don't know if that makes sense. Does it make sense to you? Hello?
Yes, it's clear. That's clear.
To the lady who asked the question? Okay. I will assume she got it because I'm not getting any response from her. Now,
yes, sorry, I did get it. Thank you.
Okay, yeah. So we're going into now machine learning and deep learning. Now, deep learning is often said to, not often, but deep learning is a subset of machine learning. But how exactly do you tell the difference when you're working with something that is on deep learning and then something that you're training for machine learning? Now, the one thing that you need to know is in deep learning, you need tons of data sets. Like you will not work with just 7 or 6 or 10 data sets for it to work. Now, the difference is when it comes to machine learning, you first have to get the inputs. Then you want to do the feature extraction. So we were talking about features such as nose, legs, and all that, or descriptions. So you want to pick what exactly are these things that define this as a car. Is it the wheels defining it as a car? Is it the screen? Is it how it moves? What is it that makes this thing a car and not a motorbike? Or what is it that makes it a motorbike and not a normal bicycle? So in machine learning, you have to define the features. You have to pick the features from whatever it is that you want to train. Then from these features that you have picked out, now you want to be learning from it. So from these various data that you have picked out, and these particular features, let's say these features say that this is a car. So you want to train your machine to identify a car based on the features that you have stated, but not really based on the whole input as a whole, based on the feature or the features. Now, based on this, once it has learned, then it's going to give you an output. But now what exactly is deep learning? Because they're gonna sound the same. If you look at the image at the side, without clearly seeing it, you'll assume that it is one and the same thing as machine learning. Now you go into deep learning. Let's look at the human brain. The human brain is made up of neurons, right? Now, deep learning was actually inspired by the structure of the brain, hence the name artificial neural networks. Now, neural networks basically refer to computing systems that represent the human brain or the animal brain, whatever brain it is that you want to work with. Now, in deep learning, you are not going to separate the features and the learning process. Deep learning is basically what we humans have, the intelligence that we have to tell an animal without necessarily looking at each and every feature that it has. So we are combining the feature extraction and the learning to be one thing. We do not have to sit down and train this model saying, if you see 4 legs, that is a 4-legged animal. If you see 2 legs, that's a chicken or something. But in this particular case, you are going to be basing it based on the fact that you're training a model to operate the same way as a human brain, which now states that as much as it's a very effective way of doing things, it's quite intelligent as compared to any other way. It makes you tell that you actually need a very high performance machine, and you really need lots of data to reference, not to reference to bit, to be your point of reference actually. Now in deep learning, I want us to take an example of customer support. You ever been in a scenario where you think you're talking to a human being only to realize you're talking to a machine? I don't know if anybody has ever been at that particular point. Anybody? Or Kenya's example for this Safaricom AI called Zuri. When you look at Zuri, if you're having a chat with Zuri on WhatsApp, Zuri makes you feel like you're having a human interaction. So deep learning is basically makes you feel as though you're interacting with a real human being in instances that you're not. Example is the self-driving cars. The reason as to why the ones that Apple has made, Tesla has made, it's called Maya, I can't remember the other company's name, but they use deep learning. And what this is telling you is, how does the car know it's supposed to brake without necessarily being told to brake? Or how does it know it can go increase its speed or reduce its speed? How does it know that this is its time to take a stop when it's not supposed to take a stop? Now, because it has been made in a way that it is able to behave with the same intelligence, with the same feel like a human being, to reason like a human being. So this is what deep learning is about. It's about training your model to operate or to have the same capabilities as that of a human brain. It does not have to keep on referring, because these examples already exist, and from what it has observed on its own, it's now able to tell without the need to go back to referencing at all particular points. I don't know if that was clear. If you have a question, again, feel free to stop me. If you have a contribution that you want to make, feel free to stop me. Okay, logistics, Nick says that is okay. Anybody else who didn't quite get it or wanted to add something before I continue? Anybody? Okay, so I had this whole slides on.
Wait, I have a question.
Yes, go ahead.
So deep learning is like talking to like a real person, and machine learning isn't really talking to a real person.
No. So deep learning is a subset of machine learning, but in this particular subset, so remember we said machine learning is a subset of AI, then deep learning is now a subset of machine learning, but now it's a more complex subset. And what means is it's not going to keep on referencing based on features. It's going to behave the same way as a human being would. So it has been inspired by the human brain and animal brains. So how do we tell the differences between a cat and a dog? We just have to take one look at it. We don't have to keep on saying, oh, that's how a dog looks like, because we already have lots and lots of data sets that were input when training us, so that we don't need to keep on referencing. So how are we able to group images based on, if you've ever used Google Photos, you realize your photos are grouped when you go to albums. There will be for people, there is one for selfies. So how exactly is it able to do this grouping? It's the same way when you find your own images, you'll be, oh, this is a selfie. So using deep learning, it's able to assume the characteristics of the human brain. So it's not the same as machine learning, but it is a subset of machine learning. And hence, when you're looking at deep learning, you need a higher computing power. You will not, if you want to work using a CPU, you're going to take forever. So when you think about deep learning, you think of getting a graphic processor unit, because it's going to consume, it needs a very high performance machine in order for you to have the best results, or in order for you to be fast enough. Then in terms of data, you need to have lots when you're going to be training it as compared to in a machine learning model, because you don't want it to keep on referencing at all points, but you want it to be able to assume that this is something that it has seen severally. And so this is what it is. So it doesn't have to keep on going to the data set that you have created. So there's the data bit. It needs more than machine learning. There's the performance bit. Machine learning models can be trained on a CPU, on a central processing unit. But when you're looking at a deep learning model, then it becomes more complex, because it's taking the performance of a human brain. So how do human brains think? How do we think about issues? How do we identify items within our surrounding? We take one look at it and we know what this is. If I look at a dog, I'll say, oh, this is a dog. I don't have to go back to the data set and say, this is how a dog should look like. I think this is the dog. So it's more accurate, but needs a high performance machine. But unlike in machine learning, it's accurate, yes, based on how you train it, but you don't really need excessive amounts of data sets. It's good to get as much as possible, but the computing power is not as much because you have separated the features, and then is when you do the learning. I don't know if that made sense to you, Karen. Hoping I pronounced your name well. Did that make sense?
It did, thank you.
Okay, great. Anybody else with a question?
I have a question.
Yes, Wakili.
Now, you talked about artificial neural networks.
Sorry?
So you talked about artificial neural network.
Yes.
So my understanding basically is that this is a mirror reflection of a human brain.
Yeah.
And then you gave an example of probably machine operation. So let's talk about, for instance, operating a truck. And this is a truck that is self-driven.
Yes.
So basically, the truck is driven. There's no driver, so the truck is self-driven. So my question is, what exactly are we training here? Because do we have some machine, some central place where we have a machine, so we are tracking the truck, or the truck has probably a machine within it that is already that has already been programmed. I don't get it. I mean, if you could explain further.
Sure. So when it comes to deep learning, you don't need human intervention to perform an activity. So neural networks are basically computing systems that represent human brains. So you're still training a model to do something. So it's not going to do it without existence of a machine. But basically, you would be programming a chip to perform given activities, right? You would be performing this. So a chip, like you would be stating, this is what you want, like this is how it's going to work. But you're not going to be needing any human intervention. When it comes to machine learning, you may at some point need human intervention in terms of you need to be the one stating the features that you want it to reference to in the data set. But now when it comes to now this self-driving car, so assume you want this truck that you have said to be able to when it gets to a particular point, let it start doing the digging on its own. So how does it know that it has got to that point? Or let's say it's a truck ferrying sugarcane. How will it know that it has got to the point? So it has been programmed to move from one distance to another, right? How does it know it's supposed to stop? The human brain that knows how to drive knows when to stop. So when you're looking at training this computing systems, you're basically telling it, this is the operations. I'm not going to be there, but this is what happens. So hence the need for the high performance machines, because you're going to structure it the same way a human being would think about things. There are not so many deep learning models because of the data and the costs. The cost of just getting these high processing machines is quite expensive. But in companies, most of corporates, you'll see them using deep learning as compared to machine learning, because then they're able to not really be there at all particular points of this machine's functionality. I don't know if that makes sense.
That made a lot of sense.
Yes, but
just one more question.
Sure.
Okay, now on a point of juxtaposition, for instance, what is the main difference
between
machine learning and deep learning?
Okay, so the difference between, let's look at the image, right? Clearly stated. In machine learning, you have to define the features that you want it to look at, right? So you have to state, this is the features of this particular animal that makes it a dog. These are the features that makes it a cat. But in deep learning, you're not stating each and every feature. You're looking, let's look at the brain as having very many neurons connected together, right? So in this particular case, everything is working at the same time. There's the feature extraction going on, and there's the learning going on at the same time. So there's this whole working together. You're not going to be doing them as individuals. You're not going to be doing, okay, so first let's do the feature extractions. Let's take the features of a dog. Then now let's train our model based on these features. But in this particular case, you're identifying the features and learning at the same time. I don't know if that makes sense.
Thanks.
I guess I can go in depth if you want me to, but because of time and since we have a very short quiz, I will be able to create time to have sessions if anybody has questions. I don't know if that would be okay with you, Joanne. John?
That is fine, Alela. Go ahead.
Okay, great. So I had planned to talk about the industries in which AI is applied, but then I realized it's part of the fourth module. So I won't be covering that. But since there's so many techies in the room, and people who also just want to get started in AI, sorry, just let me know if you're still able to see my screen. Okay, great. So I'm going to share these links with Joanne and she'll be able to share them with you. You can go to the Google Digital Garage to give you an intro to machine learning. You can go to TensorFlow to just help you get started on machine learning, or Google AI or the Amazon Web Server. So these resources are just going to help you get started on developing your own modules. How do you think about it? And what I'd say is don't look at it as a very complex process. So look at it as a learning process. So you're trying to learn something. What is it that you need to do when you want to learn? So without trying to make complex systems, I would say start small. Start with the training. We use this cat and dog example. So why don't you train your model to differentiate between a cat and a dog first? Or to differentiate between somebody who's putting on a mask and not putting on a mask. Then from there now is when you can move to the more complex bits of it. So that's all I had for you today. I am going to jump straight into the question segment to just ensure that at least everybody was with me and I didn't lose anyone. So taking you back to Slido, if you don't mind, I'm going to stop sharing my screen and share the other tab. So let's go back to slido.com, the one we used, and just answer a few questions to check just do a knowledge check, like maybe we can expound further if there's something we missed out on. Then I'll leave it to Joanne to talk about the certification. Okay, so let's go back to slido.com and we can use the link. The pin that was earlier shared. So I'm going to just share my screen. There's so many things running. Okay, let me just share this. Okay, sorry. Sorry. Okay, so just sorry about this. There's so many things running on my machine at the same time. Okay, great. So it was good to see that people were joining from everywhere. If you didn't answer this, just feel free to answer it still. So I'm going to jump onto the quiz segment. Use the same pin 42286. I am launching the questions in. Okay, let me see everybody joining first. Let's join. I want to see everybody joining. So join the quiz using 42286. This is exciting to see. Okay, 1, 2, 3, 4, 5, 6 people have joined. Let's join. It's not even, they're not complex things, they're just things that we have discussed. So at least to do a brain check, just see if everybody is with us. Okay, it's 42286. 42286 is the pin to use. 10 more people to join, then we can get started. So go to slido.com, game pin is 42286. Okay, 12 people, come on, 8 more to go. Okay. 7 more to go. Or we can start at 15. At least we'll be able to tell who our leader, who wins this. Okay. 14. Okay. Great. Okay. So winner, if we have one winner, we may have multiple winners, but if we have one winner, I'll pay for the certification from Joanne. Okay, great. So we have 15 people. I think we're good to go. Joanne, give me an okay if we're good to go.
Yes, I say we have the minimum threshold, which you talked about is 15. We can go ahead.
Okay, so let's start with the first question. Which one requires a larger data set? Oh, the biggest, like, requires so much. Oh my, everybody got it. Okay, great. Which amongst this is not a branch of artificial intelligence? It's timed. Oh. Okay, take a guess on what the answer is. Yeah, so we talked about artificial narrow intelligence, general intelligence, and super intelligence. So neural intelligence is not a branch of artificial intelligence. We can easily get that confused. Oh, you're changing your answers. So deep learning is the same as machine learning. False. Deep learning is a subset of machine learning. Let's not get this confused. So deep learning is a subset of machine learning. I'm seeing the polls are changing, so let me jump to the next one. Which one is the most efficient processor to train a deep learning model? So we have the solid state disk, GPU. Anybody who wants to spoil it? Like, we have 6 more answers to go. Okay. Somebody said none. Okay, central processing units. Okay, so the correct answer is the graphic processing unit. The GPU is a very powerful processor, and it makes it quite easy to be doing deep learning as compared to anything else. Okay, great. That is all that I have. I'll be able to see. So who won this? So let's deactivate the quiz and back to. So for this particular one, let's see. I'll be able to tell the winners, and based on that, I'll share with Joanne a coupon for one particular person. Okay, great. Back to you, Joanne. I don't have anything else. Maybe you can take us through the certification bit, but before that, anybody with a question? Anybody with a question? Questions? Questions? Okay, if there are no more questions, let me just share my screen so that Joanne can take us through the certification in case we missed the conversation on it.
Thank you, Alela.
Yeah.
Who is the winner? Who is the winner?
I have not checked the results, but I'm going to check the results after this call. Or should we check?
Yes, why not?
So many tabs running on my screen. Okay, just give me a minute.
Okay.
Okay, so let's see, which one is it? Is it this one? Are we able to? Oh, this is how we were supposed to tell the winner. Let's see. Oh, okay, so John Ngunjiri. Wait a minute. No, these are the ones who've joined. Anybody knows how we can tell our winners? Or view results. Okay. But it's not able to tell us who won. Okay. Who needs to be sponsored for a certificate? Since we all tried our best.
Yes, we did.
Who needs?
Me?
I'm waiting for the person who said me first. Who said me first?
Catherine.
I think.
Okay, so Catherine, it is. It's called being bold, be the first to say. So, Joanne.
So we have Catherine, right?
Yes.
I think Hazel posted it on the chat before anyone talked.
Oh, okay. So who posted it on the chat first?
It's me.
Oh, okay. Catherine, would you leave it to Hazel? But anyway, Zoan will have to talk about.
Let me pay for Catherine. You pay for Hazel.
Yes.
Is that
Hazel,
fair?
yes, it is very fair. Hazel, you'll get certified when you complete your coursework. Thank you so much for staying tuned, and it's great having all of you. Have a great rest of the day, and handing it over to you, Joanne.
Amazing, amazing, Alela. That was so informative. Thank you so much. Thank you. Really appreciate. So, yes, Alela, thank you. Before we move on, before we almost finalize, do you have any general question? It doesn't have to be about the lessons. It could be about the lesson, yes, but it could also be general. We're happy to answer that. Any question? Okay, congratulations to attending the quiz, and I think Alela, you can attest that most of the people understood what you were talking about, because everything was clear. The questions were directly related to what you taught, and I think we're good. We're at a good place beginning with what you've told us. Thank you very much. So let me introduce the certificate concept. So Techmindset Africa is in the mission of sensitizing, empowering, educating Africa about technology. Let me put my video on. People might be wondering who is this who is talking. So can you all see me? I don't know if you can see me. Can you see me? Yeah, great. So Techmindset Africa is about sensitizing, is about educating, is about empowering people in Africa about artificial intelligence. And why people in Africa? I'm not saying that we're not knowledgeable. Most of us know about artificial intelligence. As a matter of fact, the fact that you had the lessons in the past, you heard about the announcement, you wanted to join it, you must have known basically what it's all about. And we're in this space so that we're able to interact globally. We are able to solve things in Africa in a faster way, because most of the times when things come to Africa or we get a glimpse of something, we tend to want to learn about it instead of taking proactive decisions to do that. And that is why we want to reduce that gap. If we are going to have a doctor operating on a patient, a surgeon operating on a patient, or a doctor treating a patient, or a physician etc., taking physical services to people who need them, then they must have the basic knowledge that there's a quicker and faster, there's a quicker way, there's a more efficient way to do that. If you want to know how to talk to someone in the States or someone in Nigeria or someone even in Kenya in a faster way, you would know then there's a quicker solution to that. Then you start strategizing on that. And that is why we're here. That is why we want to educate you and me so that we are in this space faster or before anyone else gets the glimpse of it around the world. So what am I saying? The fact that we're going further and offering this, we're also trying to help those people who do not have access to computer like what you're doing. Right now, anyone who's in this class has access to internet, has access to a laptop, has access to a phone, a mobile phone, has access to a tablet. And that is beautiful. We are privileged to do that. But there's that person who is eager to get into the job market, and or rather who wants a start in life, and they would need a helping hand. So we're also using this platform to be able to do that, to help that person to either get them a laptop or invite them to our premises to learn something, to learn basic computer, to learn how to switch on a computer, to learn how to get onto social media, to learn how to basics, you know, AI basic information, to have a head start when they get into the market, because companies are restructuring, our CEOs are getting smarter, that they're recruiting people who have basic knowledge. They're recruiting people who at least know what artificial intelligence is, people who have strategic ways to move the company forward using artificial intelligence. People are coming up with businesses. They want to employ people who know how to work with machines, or at least know what to do when the machines are here. So it is very important that we don't leave other people behind. And that is why through this platform, and by you getting a certificate at only 1,500, we have the opportunity to educate one extra person. We have the opportunity to let a recent graduate, for example, to learn the basics of artificial intelligence and let them. We can't solve every problem. We can't educate everyone, but we can create opportunities for a head start. So what am I saying? The fact that you're learning about artificial intelligence, it is good. You go out there and say, yes, I know about artificial intelligence. I'm good at it, but how will you show that you're able to do it? How, if someone asks you to demonstrate, how will you do that? And we're offering that opportunity at a fraction of the cost of the market today. At 1,500, you're able to get a certificate and go further and create your own model using the tools that we are going to expose to you. And also you're able to use a certificate in your networks. You're able to use a certificate in possibly if you're employed, to get extra value in your CV. You know, you want to stand above the rest. And other than that, you're able to look at it every time and know that you have a part to play in the artificial intelligence world. So what I'm urging each one of you, if you have the opportunity, if you can, get a certificate at the end of this course for your own good and for the good of someone else. It is important. It's something that you can keep and share with your children generation. It will remind you about the purpose of what you're doing for the next generation. As a matter of fact, I think I've seen someone very young in this forum. What's his name? I think it's Kieron. Kieron, if you don't mind me asking, how old are you? Kieron, can you hear me? I think he had network issues earlier. I don't think he's over 18. So these are the generations we want to sensitize. And it's very important that we set an example. It's very important that when we're talking to them about something we know. So I'd urge everyone, okay? It doesn't matter what your intentions are with this class. Please get a certificate if it's not for you, for someone else, all right? If anyone wants more information about this, kindly WhatsApp us at +254, that is the Kenyan code, 725 64 84 46, in case you're not in that WhatsApp group, because that's the line, that's the number that's there. All right, contact us, will register you. You don't have to pay for it now. You can pay for it at the end of the lesson, so that at the end of the 6-week course, then you make your payments, you get the certificate. We'll also tell you who you're sponsoring. There are two models of sponsorships. There's the model where you pay for a student in full. So what we'll do, we'll share with you the kind of students that are going to come on board, and we'll tell the students that they have been sponsored by this particular person. But there's also the model where you learn, you get the certificate yourself. But that means every 3 persons, every 3 certificates, you have educated 1 person. Every 3 certificates you get. For example, if I get a certificate, if Alela gets a certificate, if Nicole gets a certificate, the 3 of us have been able to sponsor 1 person. So the fact that you just get a certificate for yourself, you have helped someone. And we really appreciate. But don't you worry, we're not going to stop teaching you. We'll continue teaching you. We'll continue putting on the lessons. We'll continue sharing the notes. And we'll be happy if you share this knowledge to someone else. I think that is all I can say. Thank you. Unless anyone has a question. I'll be looking at your chat.